Hello, everyone. We're back, episode 15 already. Jeez, Underscope podcast. Today we have a special guest. Today is Dr. Christopher Dieni, who is a biochemistry professor from Colorado Mesa University. Which, for those of you who have been listening to my podcast, this is my first guest that's not a Widener faculty. However, though, he is a teak. He is a brother of Tau Kappa Epsilon, which is lovely. We always love to hear that. And we'll talk about Greek life a little bit later in the podcast, but yeah, I'm excited to have you on. How you doing, Chris?
I'm doing very, very well. Thank you so much for having me on. It's always great to be chatting with a brother of Tau Kappa Epsilon. It's actually been a while. I am at a university where there was formerly a chapter of Tau Kappa Epsilon, and right now in the heat of the moment, I cannot remember for the life of me which chapter it actually was, but it's been inactive since something like the 1990s, and it's been a while in my career path, which I'm sure we'll get into, that I've been in the same place as an active chapter. So it's always great to talk from a brotherly perspective and a scientific perspective in the same conversation.
Yeah, I think. Yeah, the more I love having these scientific conversations. It just makes it all better when you have that, when you're also in the same fraternity. But Chris, without further ado, let's hop right into this. So let's do some introductions, because I don't even know where you're from, but that's okay.
I am from the Great White North. I am from Montreal, Quebec, Canada, Canada's second largest city, sort of heading more or less due north of New York. You know, just keep heading north, cross at Plattsburgh, and you'll hit it. And I was born and raised in Montreal. I lived in Montreal up until the end of my undergrad at Concordia University. And then thereafter, from basically 2004 onward, I'm from a whole bunch of other places. But the original place is Montreal.
My best friends, like before we could drink alcohol legally, they would go to Montreal to celebrate the New Year's. So my friends have done that twice. They made the trek up to Montreal. I've never been there, but I've heard great things about Montreal. Is there anything in Montreal that you think when people go to visit there, they gotta go see? Like they gotta try out?
I mean, just in general, you know, depending on where you're from, as I've said, it's Canada's second largest city. I think altogether it's got a greater metropolitan population of something like 4.1 million or something like that. I'm kind of quoting this more or less exact stat because that seems to constantly come up in conversation of how big is the city, and it's about that. But I mean, you know, it's this city where it has flavors of everything. You know, it's historically a really, really important part of North America. It's a major port city. You know, it has aspects of, you know, British history, French history, Native North American history. There are, I mean, if you're a foodie, it's paradise for you. There's anything and everything to eat and drink in a place like Montreal. There's museums, there's historical landmarks, there's, you know, boat cruises up and down the St. Lawrence River, because Montreal is actually an island. There's, I guess, a little bit outside of the city, there's, you know, nature. I mean, Canada's not very densely populated, so you've got the Canadian Shield. Depending on the type of year, you've got skiing at pretty exclusive resorts like around Mont Tremblant, stuff like that. So, I mean, there's whatever it is that you're interested in, there's a pretty good chance that you can find it in Montreal.
And can you speak French? You can, like, fluently?
Oui,
wow.
Absolument, oui.
Oh man, I took French.
No, but so I mean, it's actually you know, it's actually part of the law, because the primarily official language of Quebec is French. Canada as a whole has two official languages, English and French. Particularly if you're looking for jobs, specifically government jobs, anywhere in Quebec, you're going to have to speak French. If you're looking for government jobs, not in the province of Quebec, but in our national capital, Ottawa, Ontario, which is for all intents and purposes our Washington, D.C., given that Canada is officially a bilingual country, if you're looking for a federal government job, you do need to be bilingual, both verbally and in writing. So yeah, I mean, as part of the education system growing up in Montreal, in the province of Quebec, you learn French. And arguably, Montreal is probably one of the few places in the entire province of Quebec that you can actually even learn English at all. There are parts of Quebec where it's 100% entirely in French. And then it's a challenge to go from those portions of Quebec to anywhere else in Canada, because then it's a culture shock of having to learn English. But, you know, from a very, very young age, and even in my own household growing up, it was pretty much bilingual. You know, you would immerse yourselves in both languages.
Yeah, I took my first semester of freshman year, I took French because like I had to, for like the chemistry degree, you know, you have to take some humanities, whatever, and that falls under humanities. But I would love to be bilingual, but like unless you're learning it at a young age or you're speaking it 24/7, you're never gonna pick up like a language. Like I swear I live by that. French would be pretty cool to learn, but is it true though? Let me ask you this: is it true that French Canadians and French people in general do not like Americans? Is that true?
I don't know. I mean, I think, you know, it can be finger pointed that any group of people does not like any other group of people. I find that paradoxical because, you know, if people from Quebec are going to go on a vacation somewhere, and it's not, you know, the type of vacation where they're going to have to board a plane and go, you know, intracontinentally to somewhere like Mexico or something like that, or overseas to Europe or whatever. Chances are they're going to be either going somewhere else in Canada or they're going to be going to the United States. I mean, especially being from Montreal, I remember that back in the day, growing up back in the 80s, you know, despite the lofty exchange rate, it used to be cheaper to, you know, go with or, you know, as a young one, be dragged along with family members to go do shopping in places like Plattsburgh or Burlington because of all of the sort of outlet malls over there. Like, you know, you hear back in the day, the Burlington Coat Factory and stuff like that. Even though the exchange rate was unfavorable. So, I mean, Quebecers, if there's this notion that they don't like Americans, they spend quite a bit of time in the United States nonetheless, given the proximity of the borders. So I wouldn't paint with such a wide brush in that case.
That's fair enough. Because I always hear whispers about it. I'm like, I don't know if that's entirely true, but you know, whatever. But so you grew up in Montreal. That's pretty cool. And then you went to Concordia. So that's where you got your undergrad in biochemistry.
I did, yeah.
Where is Concordia? I don't even know where that is.
Which campus? So Concordia is actually the result of, I'm going to be a terrible alumnus. Concordia is the result of a merger between two prior institutions, Loyola College and Sir George Williams University. And when did this occur? This had to have occurred back in the late 1970s when my father was actually an undergraduate. I can't remember for the life of me the exact year that this happened, but it was late 1970s. So Concordia came into existence as a result of the merger between Sir George Williams University and Loyola College. And so as a result, both the campuses of Loyola College and Sir George Williams University remain part of Concordia's campuses. So the Sir George Williams campus, as it's now referred to, of Concordia, is actually smack right in the middle of the downtown core of metropolitan Montreal. And so that's actually where I started the first couple of years in my undergrad at Concordia, was in these downtown buildings. And it was very surreal because it's not at all what you think of as a stereotypical university, which is a nice green space, you know, like these red brick buildings, old sophisticated looking buildings with this campus of people kind of lying around on hammocks or throwing frisbees or whatever. I mean, you step out of an academic building and you are on a busy metropolitan sidewalk of a street where you've got cars buzzing by. And when I actually started my undergrad, Concordia was going through a pretty pronounced growth phase, such that they did not have enough classrooms to accommodate the number of students. They had actually taken over a mall that was going sort of out of business a couple of blocks away, and took over the old Cineplex Odeon movie theaters in the basement of that mall and converted movie theaters into lecture halls. So I started off my undergrad attending these lectures, you know, in inorganic chemistry, physical chemistry, whatever, in a converted movie theater. So that's where one campus of Concordia is. The second campus, which is the Loyola campus, which originated from Loyola College, is actually off to the side of the downtown core, so it's not quite as busy. And it has a little bit more of that traditional university campus feel, where it is, you know, it is somewhat of an enclosed campus with green spaces. And so that's in a suburb or a municipality of Montreal called Notre-Dame-des-Grâces, which is, I guess, roughly translated to Our Lady of Grace or something like that. You know, owing to the French Catholic roots of colonial Montreal and Quebec and New France. But yeah, I mean, they're both in the island of Montreal, with one campus being smack in the downtown core and one campus a little bit off to the side. And we now have, you know, some shuttle buses that run between the two campuses.
That sounds like, well, it depends on if you like the city life. I personally don't like the city life, but I think if you grow up in Philadelphia, another big city, you might like that college feel. Personally, to me, I wouldn't be interested in that. Did you ever, when you were an undergrad, did you go to like the ice bars? Are there ice bars in Montreal? Like they're igloos or something like that?
No. Are you thinking mainly of like the ice hotel that you would find?
Maybe that's it.
I mean, it's, you know, at the end of the day, you know, Montreal gets cold, right? Like any place in Canada gets somewhat cold. The reason that I know, especially having grown up with the metric system, that the equivalence point, or one of the equivalence points between the Celsius scale and the Fahrenheit scale is at -40, where -40 Celsius and -40 Fahrenheit are the same thing, is because I regularly encounter temperatures of -40. But still, I mean, like you'll have regular, especially now with climate change, you're going to have days where in the middle of winter, in the middle of December, January, you're going to have, you know, above 0 degrees Celsius, above freezing temperatures. So you don't have that much. Plus the ambient temperature of a busy city and heat being radiated from vehicles and buildings and things like that. It tends to be, you know, warmer inside the city than it does outside the city. But no, there are no ice bars or anything like that. There are obviously hockey arenas, but nothing like in the ice bars.
It's the Canadians.
I'm sorry?
The Canadians are there, right?
Right, the Montreal. Well, yeah. I would hope. What,
well,
you grew up in Philadelphia, so
yeah,
yes, our rivalry, Montreal Canadiens, are in Montreal.
Okay. Wait. So who's in Montreal then? It is the Canadians, right?
Yeah, Montreal Canadiens.
Okay. Yes. Yeah. I know Toronto's got the Maple Leafs. There's actually a few of them. I don't remember.
Toronto Maple Leafs, Ottawa Senators, Winnipeg Jets, Edmonton Oilers, Calgary Flames, Vancouver Canucks.
There's actually a lot more hockey teams. Holy crap, I didn't realize that.
Well, I mean, if you saw with NHL's announcement yesterday that, you know, we're going to be playing in certain kind of divisions in our abbreviated 2021 NHL season, basically to avoid frequent crossing of the border due to COVID restrictions, essentially all of the Canadian teams are essentially going to play each other and weed out until you get to the best team before we actually have playoffs, where I guess the last Canadian team standing is going to play whatever last US team is standing or something. I don't know, something like that.
I didn't see that. So that's, I see why they did it, but okay. I mean, all right.
Because I mean, it's not trivial at the moment to cross the border. I mean, you know, you may have heard of that plight of oh, what's that town in Washington State that is actually not contiguously connected to any other part of Washington State, but is actually connected to part of the landmass of British Columbia, where they're just like completely cut off because they can't cross the border.
Oh, wow. I didn't hear about that either.
Fort something. I can't remember what Fort something in Washington State. So it's not trivial, unfortunately, to go across the border at the moment. So hockey is taking on that form at this time.
Well, we'll see what happens. I always wanted to get into hockey and then never do. Like it's just not something I can get myself into. You a big hockey fan?
I actually became more and more of a hockey fan kind of as I got older. I don't know, maybe in my youth I just didn't have the patience for it. And the reason I think that I got more into it as I got older is because I actually started going to see more games in person, which is, you know, a completely different experience versus watching a game on TV. And you know, certainly as I got older, I began watching hockey. Even when I wasn't in person, I would watch it more in a bar with friends, which also is a bit of more of a different experience than simply watching the game at home, whether you're by yourself or you're with a person or two. So I think that community aspect of watching with friends at a bar or a sports restaurant or something like that, or even going in person, changed my idea of being a fan for hockey.
Yeah, I can draw definitely a parallel to soccer because I'm a big soccer fan, and a lot of people don't like soccer, and like that's fine. I don't really like hockey, but I would say in both cases in those sports, going to those games is like so unreal. Like it's literally unreal. So I look forward to being back in person in those sports. Okay, so you're at Concordia. You got your undergrad in biochemistry. Eventually, got your Ph.D. in chemistry. But starting in undergrad, what was it about biochemistry that you said, you know what, I really want to go pursue this? Was it always something that you grew up with, or like how did you stumble upon it?
Process of elimination.
Very scientific.
Yeah. So so there's a little bit of a quirk when it comes to the Quebec education system, that you actually start your post-secondary studies a little bit earlier than university. So actually we go up to, in high school, grade 11, or what we also call secondary 5. So, you got your elementary school, you've got your high school up until grade 11. In other provinces in Canada, you would go up to grade 12 in high school. So there's a missing year there in Quebec relative to other provinces in Canada. On top of that, undergrads in Quebec, undergraduate degrees, are 3 years as opposed to 4 years. So where are those missing 2 years? Where is grade 12 and the first year of your undergrad? Well, we have a separate institution, which is, to translate it again from its French acronym, it's sort of a college of, or colleges, because there are many of them, of general education and professional education. And they're basically institutions where you can either do a 2-year pre-university program or a 3-year technical degree. It's sort of like a pre-university prep, which includes your first year of your undergrad, and also vocational degrees or community colleges, kind of all rolled into one. And you can take whatever path depending on where you want to go ultimately. So I entered into what was technically considered to be my post-secondary studies, or almost my university level studies, with the idea of actually going into engineering, probably mechanical engineering. And I hit calculus 1, and I hit mechanics, and that was that. I was no longer interested in engineering thereafter. That being said, so my first semester at this particular college prior to Concordia, which is called John Abbott College, you know, I did mechanics, I did calculus 1, and I did general chemistry 1 with a bunch of other courses like English, humanities courses, what have you.
Sure.
But I mean, those 3 science courses almost did me in right then and there, particularly calculus 1 and mechanics. And so very, very slowly but surely, the notion of going into anything engineering based or anything engineering related began to dwindle. But as time went on, I began enjoying and liking and eventually loving more and more my chemistry courses and my biology courses. And my brother, my cousin had done an undergraduate. He's a few years older than I am. He had actually done an undergraduate degree in biochemistry and told me a little bit about that. And, you know, I liked the idea of that. So it was sort of a combination of liking courses in chemistry and biology while also being somewhat pushed away from some of these physics and math courses, which is ironic because, you know, in the long run, in any kind of any sort of STEM discipline, you end up having to rely to a greater or lesser extent on the interdisciplinarity between all of these different fields, whether or not you actually like them. So, you know, things like calculus and physics came back to bite me later down the road anyway. But yeah, I mean, it was that sort of attracted me. And then I went into Concordia, where I actually applied for a full-fledged undergraduate degree in biochemistry, because when you're at these pre-university colleges, you don't actually select a major like chemistry or biochemistry or biology or mechanical engineering. You just sort of select a science major or a pure and applied science major. And that's where you do all of your courses in mechanics, electricity, magnetism, optics and modern physics, Cal 1, Cal 2, linear algebra, Gen Chem 1, Gen Chem 2, general biology 1, and then a few other science courses where you can choose from. And I guess kind of the beauty of that system, which is, again, unique to Quebec, is that it allows you to determine what you like and dislike from a broad scientific perspective before then progressing to university and choosing to pursue a specific major.
Yeah, I was thinking about that because like I was thinking about when you told me like, you know, you go to this like basically this pre-university, I guess. You know, it was kind of considered like a community college vocational school. Like that's kind of how you can kind of think of it. And I was like, that sounds really weird. Like, why would they do it that way? And then I was like, well, there are a lot of students who go into university in America and they declare a degree, and then all of a sudden, it's like, oh shit, like I hate this. I don't know what is going on. I hate what I'm doing. And then they have to switch up so quickly, and they have to decide that within like 2 years. So I guess if you could bypass that by going to a pre-university school. And I think that's really smart.
And that's the norm. Like I mean, you must go through that path. You cannot jump straight from, in Quebec, you cannot jump straight from grade 11 from high school directly into university. If you originate in Quebec, if you were born and raised and lived your life in Quebec, you must go through this sort of pre-university college route. The beauty of that, as you say, is like, yeah, you don't go into university sort of declaring a major and then winding up thinking, what the hell did I do? I have to change my major.
Right.
And generally speaking, tuition in Quebec is dirt cheap. Absolutely dirt cheap. You know, back in the day, I mean, I did my undergrad in the early 2000s, and I think that my annual tuition was less than $3,000. However, to actually drive the point a little further, the tuition for these pre-university colleges, these CEGEPs, is even lower. So, I mean, per semester, they don't even call it tuition, they call it a registration fee because it's very heavily subsidized by the provincial government. Back in my day, $120 per semester. So $120 per semester to take university level courses, because it's the same general chemistry 1, general chemistry 2, all that you would be taking at the university level. And you're basically, for all intents and purposes, an undeclared science major. So if you're like me, where you have the mentality to say that, oh yeah, I want to go into mechanical engineering and then take Cal 1 and mechanics, and hell, I don't want to touch this with a 10-foot pole anymore. You don't have to go through the logistics of changing your major because you've never declared a major per se. You're just simply a pure and applied science student. And nothing that you do will be a wasted semester, for the tune of, again, I'm sure it's increased since I was a student, but $120 per semester. So there's actually some beauty to it. There is, of course, for every pro, there's a con. I saw people who entered this college at the same time as I did, and you're supposed to only spend 2 years there because, it basically encompasses grade 12 and your first year of your undergrad. So after 2 years, you're supposed to move to a university and pursue a baccalaureate program. But because it's only $120 per semester, I mean, it's like pocket change. I've seen people spend 2.5 years, 3 years, 4 years, and then eventually just kind of never get out because they keep switching what actual program they're in. Even like going as far as to go from pure and applied sciences to social sciences to fine arts. I mean, you can basically try it all for 1 semester at a time, for 1 year at a time, until you finally discover your passion, but wind up a little bit drifting aimlessly in the process of doing that.
I mean, that's like almost literally unheard of, like in America. Does it kind of like make you think, like, why does America do it this way then? Because I'm thinking why we do it this way. I don't even know why we, like, that seems really smart to me, but I guess it is what it is.
I mean, I've never, with my foreigner bias, coming in as a Canadian to the United States, I've never quite understood the tuition being what it is over here. I mean, even like I say, Quebec has lower tuition than other provinces in Canada. I don't think the highest tuition at the most expensive university in Canada even compares to the tuition that you would encounter in the United States. Depending on what universities are spending their tuition dollars on, I can kind of understand why they're charging some certain types of fees to students. Like, we'll get there eventually, but when I, went to Penn State and I saw like the sprawling campus of Penn State,
It's got to be a reality shift. Like, it's got to be.
It's just like, I mean, Beaver Stadium, which has a capacity of, I don't know what it is now, but I know like over 120,000 people. I mean, college sports in Canada are not that at all. I mean, even professional sports in Canada are not equivalent to college sports in the United States. So I imagine that's a big reason why tuition is the way it is in the US.
Wow. Yeah. Yeah. We'll definitely talk about that. I mean, the shift from university in Canada, I mean, it's got to be a culture shock. Like, it's got to be a whole revolution, switching over to the American universities. So you're in Concordia. Now, I guess do you think that your undergraduate education was comparable to an American education? Because at least in my undergrad, like, I have access to nuclear NMR. I have access to, all these instruments. And do you think that, like, is it comparable? Like, is it actually like comparable? Like,
yeah, absolutely. The same kind of instrumentation that you would find in a US university is what you can find at a Canadian university. In both countries, you have universities and colleges that are somewhere in the spectrum of being well-equipped or well-funded. You're going to have in the US universities and colleges that are well-funded and well-equipped, and you will have others that are not so well-funded and not so well-equipped. at Canadian universities and colleges, same thing. You're going to have, you know, some that are well equipped and some that are not well equipped. Concordia is a mid-sized university. It's referred to in the way that Canadian universities are kind of categorized into three broad categories. It's referred to as a comprehensive university, where what does that mean? What is a comprehensive university? Well, let me tell you about the two other categories. One of the two other categories is a primarily undergraduate institution or primarily undergraduate university, which is, you know, where you'd find sort of like these liberal arts colleges. They don't delve terribly much into master students or doctoral programs. That's not to say that they are not well equipped, that they don't have great endowments, because as we know, some liberal arts colleges rival other universities in terms of how much money they've got to throw around and how much they actually spend on their students. At the other end of the spectrum, there is the doctoral research universities, which are those universities which tend to have medical schools attached to them and a plethora of doctoral programs, sometimes even more doctoral programs than undergraduate programs. So Concordia was kind of in the middle of those two, being a comprehensive university. But, you know, there are master's programs, there are doctoral programs. I had the opportunity, I was fortunate enough to kind of snag a newly hired professor in one of my cell biology courses. He had just started his tenure track position, and I hovered around him like a wasp or something like that, you know, basically asking him for some kind of research opportunity in the summer. And so, yeah, I was his first ever research student. The day I walked in to the research lab in May 2002, I was the only one there amidst, you know, a mass of boxes containing centrifuges and gel electrophoresis equipment and chemicals and incubators and all that. So I don't find that, you know, my education or the resources I had access to were any different than what would be found at a US university. Actually, the difference that I've encountered, and I don't want to jump too far ahead depending on what order you've got questions for me in, but what I found that was different is that in Canada, by far and large, a lab course is not credited separately from a lecture course. So here, for instance, at Colorado Mesa University, where I'm teaching, okay, you're partial to organic chemistry courses, right? So Organic Chemistry 1 lecture and Organic Chemistry 1 lab, considered two separate courses. Different course codes, different credits, maybe even a different professor teaching them. At most Canadian universities, sure, there would be a lecture component and a lab component for Organic Chemistry 1, but they would be bundled. They would be under the same course code. They would be worth a combined number of credits. You cannot register for one without registering for the other, and you get a single letter grade for both. So because labs do not count as separate entities and do not carry their own credit values, you accumulate your credits towards your overall degree a lot slower than you would if labs were actually credited separately, which means that you have to take many, many more courses. So I didn't just, you know, in my undergraduate degree, take Organic Chemistry 1 and Organic Chemistry 2 and call it a day. I did Organic Chemistry 1, I did Organic Chemistry 2, I did Organic Chemistry 3, which was subtitled Organic Reactions. I did Organic Chemistry 4, which was subtitled Organic Stereochemistry, which was nicknamed 3D Chem, which was basically a reiteration of Organic 1 through 3, but with all of the stereochemistry and regioselectivity and all that in mind. I did, they were not numbered organic chemistry, so it wasn't like Organic Chemistry 5 or something like that. I did Natural Products Chemistry. I did an Organic Synthesis. And then I did something that wasn't actually considered an organic chemistry course per se, but was actually a spectroscopy and structure of organic compounds course. So I actually took a lot more courses in my Canadian undergrad than I have perceived being available at US universities, because, you know, they kind of jip us the credits for our lab courses, but in a good way. You have to take many, many more courses. And you know, as a biochemistry professor who has taught previously and is teaching in the United States, it breaks my heart a little bit when a student pursuing a biochemistry degree only takes, for instance, biochemistry 1 and biochemistry 2 and maybe one biochemistry laboratory course, and you know, that's it for their biochemistry undergrad. I took, as far as undergraduate courses in biochemistry, I did take, you know, something that was called Biochem 1, Introductory Biochemistry, Biochemistry 2, Intermediary Metabolism, both of which had laboratory components. So 2 labs right there in biochemistry. I took an advanced lab in biochemistry course that was dedicated more as a lab than a lecture. And then I took advanced courses in biochemistry called physiological biochemistry and protein engineering and design. So, you know, I loved my education in Canada, and I don't feel that in any way was diminished as compared to what I would see for undergraduate degrees in the United States.
Yeah, I would even say, after listening to you speak, I think the Americans are now being diminished. Because, I mean, I'm trying to think, because I'm an organic chemist, but I have friends who are in the biochemistry program, and you know, I don't even think we offer an advanced biochemistry course. Like, I'm trying to think off the top of my head. I think it's Biochem 1, Biochem 2, and maybe there's one advanced biochem course. I'm not really too sure, though, honestly. Maybe there's a lab for each one, but that's kind of all you get.
That seems to be the norm at many U.S. universities, and that, like, you know, it's even referred to in common parlance as the 2-semester biochemistry sequence or something like that, where it's just, you know, treated as Biochem 1, Biochem 2, and that's that.
And you don't even get to it. You don't even get to it till like you're a junior, maybe even a senior.
That also is, you know, and I mean, being a tenure-track professor here at CMU, and now being in my 2nd year, you know, I'm slowly, incrementally starting to get more advisees, more students to officially advise as per their degree requirements and their progress. And, you know, one of the things that I'm trying to do is make sure that they can take biochemistry courses as early as they possibly can, because certainly there can be no advanced biochemistry courses if you don't actually take Biochem 1 and Biochem 2 until your senior year. You should be able to take it as early as your junior year, but a lot of students just simply aren't advised to do so, or they've taken chemistry courses out of sequence. I mean, you should be doing Gen Chem 1, Gen Chem 2 in your freshman year, Organic 1, Organic 2 in your sophomore year, and Biochem 1 and 2 in your junior year, and so on and so forth. You know, but yeah, you see a lot of them just sort of like miss the boat and not actually do their biochems until their senior year, where they're under the gun, they're under a clock to graduate on time. So they're not just interested in passing the course for the sake of learning the material, but they're saying, oh, I want to graduate and get out of here. Again, another slight difference for my undergrad at Concordia is, I believe Biochem 1, for instance, was a you know, Organic 2 was not a prerequisite for Biochem 1, but it was a co-requisite for Biochem 1. So, so basically you can take Organic Chemistry 2 and Biochemistry 1 at the same time. And it is a little bit of a squeeze, because Organic Chemistry 2 is when you start learning a lot of your carbonyl chemistry. And, you know, carbonyls play a very, very important role in biochemistry. I mean, for instance, your amino acids, you know, your monomers of your proteins are, you know, a portion amine group and a portion carboxylic acid or carboxylate. So right there, there's, you know, an important carbonyl group. Your monosaccharides are all aldoses, which are aldehydes, or ketoses, which are ketones. So there's a lot of carbonyl chemistry. It's tight, but it works. And most biochemistry 1 courses at Canadian universities are actually course numbered as 200 level or 2000 level because of that exact reason, because Organic 2 is typically a co-requisite, and you can take biochemistry courses starting in your sophomore year rather than in your junior year. So you get to biochemistry quite a bit earlier than you would at a US institution.
Yeah, so I think that, and it definitely probably has, it's probably more an advantage, I think, than a disadvantage. So so now, well, as you move through undergrad, right? Like you're taking like all these courses, and you're really getting a plate of everything. You're really getting a whole lot of everything, and really some of the are better probably graduate courses. By the time you're a senior, your last year of undergrad, you're probably taking some graduate courses. So was your decision to get your PhD almost like a natural decision? Like, how did you come to that decision?
Oh God, no. Absolutely not. No, because, I was a biochemistry student. So obviously the natural course of action was to go into med school, because naturally when you are doing your undergrad in biochem, you must go to med school. That is the only conceivable option. And I was no different. So I applied. Of course, only a small fraction of students get into medical school, and I most certainly was not one of them. Which, in retrospect was not at all surprising, because as I tell all of my students point blank, especially now that, being a professor and not the least bit wanting to be a hypocrite whatsoever, my earliest time in pre-university college and in my first year of my undergrad was deplorable. My grades were like rock bottom. I was actually even put on academic probation after my first semester at Concordia. Now, that being said, I basically trained myself how to be a monk, how to, not have a social life, no extracurricular activities, nothing whatsoever. And by the time I graduated from Concordia, I was on the dean's list, and I was, 0.03 grade points away from having a cum laude graduation. So, I turned it around. I did a 180. So yeah, with all of that, no surprise I didn't have a snowball's chance in hell of getting into medical school. So what did I do? Well, I went to go pursue a master's degree, not because I was necessarily interested in graduate school per se, but basically to give myself sort of like a round two for possibly applying to med school down the road, to buy myself more time. But something happened. I actually ended up loving the graduate research that I was doing. It was intensely interesting. I loved the university that I was at. I loved the city that I was living in. I was no longer in Montreal at this time. I was at Carleton University in Ottawa, Ontario, which is our national capital, and kind of like a city somewhere, metropolitan area, and I don't know, 1 million people or something like that, but like really, really vibrant city nonetheless. And it was a great experience. And if nothing else, I really loved that research, and I knew that I wanted to do more of it. So one day, I think 9 months, 10 months or something like that into what was at the time my master's degree, I sat down with my master's supervisor, and he said, you seem to be interested in this. You seem to be liking and enjoying it. You're doing very, very well. You're making very rapid progress. Is this something that you would be interested in? Is this something that you would you be interested ultimately in going forward into doctoral research? I said, yeah, you know what? Yeah, like I once had the idea, or perhaps one might say the illusion, of going into medical school, and that, is a pipe dream, and I'm less interested in that. If anything, if I would wind up in the medical field, I wouldn't even at this point be necessarily interested in treating people so much as I would be in doing medical research. So yeah, absolutely. I want to go all the way to doctoral research if possible. And, he said to me, my supervisor said, well, what would be a pain would be to basically wrap up your master's degree, wind down from your master's research, write your thesis, start looking for another lab somewhere in which to do doctoral research, relocate there, then ramp up once again your doctoral research. Wouldn't it be great if you could go right until the end of your PhD without having lost the momentum that you've established here already for your master's? I said, yeah, that would be great. And he said, well, it's the process known as fast tracking, in which you would basically just remain here in this lab, and everything that you have done for your master's degree would be retroactively counted towards your PhD. I said, yeah, this sounds like, you know, a no lose situation at all. You know, what could be bad about taking everything I've done for my master's and applying that towards my PhD, as long as I'm certain that I want to go to that completion? I said, okay, what do I have to do this? He whips out a form, puts it in front of me, says, check this box, check that box, initial here, sign here. And a few months later, I basically got the notification that I was, as of, I guess at that time it would be fall 2005, I was accepted into a doctoral program in chemistry, and everything that I'd done so far was applied towards my doctoral efforts.
And what was your research in your graduate school?
So basically, it you know, as you said, I've done my PhD in chemistry simply because I know, a little nomenclature thing, right? Little detail. Concordia, for instance, where I did my undergrad, did have a department of chemistry and biochemistry, as well as a department of biology. Why Carleton chose to name its departments chemistry and biology without actually having the word biochemistry in either of those department names baffles me. So I did, you know, PhD in chemistry because I was affiliated with the chemistry department, but I was still a biochemist at the end of the day. And I was essentially working on animals that adapted to seasonal environmental stress. So kind of stress physiology, and investigating the regulation of enzymes that controlled metabolic pathways, facilitating those adaptations. So specifically, I was looking at a freeze-tolerant frog, the wood frog, Rana sylvatica, which in various parts of North America that are cold enough to freeze over, it will freeze solid during the winter. It's this small little frog, like about the size of your thumb. Average mass is about 4 grams. So it freezes during the winter. Approximately 70% of its extracellular and extra organ water actually do form ice crystals. If you take ones that are frozen and you pith them and you dissect them and you open them up, you actually see the water that has turned to ice in their bodies. And then, in the spring, they thaw, they come back to life. So what is going on at the biochemical level? What enzymes that are a normal part of their textbook biochemistry are differentially regulated in such a way that allows for adaptations that permits their survival? So one of the strategies that they use to survive is that, as I mentioned, their extracellular and their extra organ water freezes, but not their intracellular water, not their cytosol. And the way that they prevent their intracellular water from freezing, and the way that they prevent their cells from being dehydrated, is through a combination of different strategies. One includes basically the accumulation of high concentrations of glucose. So their livers decrease by mass by approximately 45% because of all of the glycogen that they hydrolyze from their reserves in their livers, and also their skeletal muscle. They break down their glycogen in the same way that you'd see by cracking open a biochemistry textbook. They break down their glycogen to glucose 1-phosphate, they mutase it to glucose 6-phosphate. They either retain that intracellular glucose, or they can in fact dephosphorylate it and export it to other organs and tissues. No different than the biochemistry that you would learn in any sort of standard metabolism course, but some things are different. They will have differently regulated protein kinases, which can phosphorylate or dephosphorylate enzyme. They may have different transcription of genes that you would not see in a mammal, for instance, which is not freezing solid in the winter. So it was basically looking at very, very fundamental classical biochemistry when it goes kind of a little bit crazy in a very, very unique adaptive animal. And it had, huge repercussions. A lot of people would be interested at looking in that sort of thing, kind of in the idea of environmental biology. For me, it was, I was always interested, having grown up in a family that was very, very plagued with diabetes. For me, it was the ability to investigate an animal, a model vertebrate that actually increased its glucose concentrations in some organs and tissues 40 times above their normal level, and yet suffered no ill effects as a diabetic human would, and actually be able to flip a switch and reverse the process, right? No A1C, no glycated hemoglobin, no advanced glycation end products, no activation of receptor for advanced glycation end products, the RAGE receptor, no inflammatory cascades as a result. How is it that a perfectly normal living organism, is able to do that reversibly every single winter and spring, like flipping a switch? And yet we, as soon as our blood glucose levels are 1 or 2 millimolar above normal, we are declared hardcore diabetics, and now we have to go onto an extreme regime of diet and exercise and medication, or whatever the case may be. So that's what fascinated me about that type of work.
Yeah, was that, well, first of all, that is really fascinating work. Do you think that there's some sort of parallel to like some sort of like cryogenesis where like we could freeze people? Like, is that kind of working there?
Yeah, I mean, that's certainly the most common question that arises from that kind of research. It would take a lot to basically see what happens in animals that can do it, right? Normally we see insects and reptiles and sort of non-mammalian animals that are able to endure whole body freezing and actually come back to life and suffer no ill effects. There aren't, giving it some thought, I don't think in all of the work that we did and all of the work that we read that other people were doing, when we would publish our papers and write our theses, I don't believe it has been discovered yet any kind of mammal that can take on that plethora of cell by cell, organ by organ, tissue by tissue adaptations to survive whole body freezing and come back with no ill effects. What we always used to say when we used to have people from different television stations and different media pass through the labs is that the clearer bridge, right, the next step that we could apply it to would not so much be whole body freezing, but rather organ preservation or blood preservation. That is much more conceivable, actually taking one organ at a time and learning what we learn from animals like frogs and applying it to, keeping a heart living for that much longer until it can get to a transplant recipient, getting some kidneys living for that much longer, getting a severed appendage, keeping it alive for that much longer, or even keeping, blood banks stocked for that much longer. Whole body freezing is still probably a long way off.
Yeah, that makes a lot more sense. The applicability of harvesting, really, kind of basically harvesting an organ, makes a lot more sense. And I guess the frogs that you're working with, you're saying they're 4 grams. God,
yeah.
So tiny.
Oh, absolutely. We used to basically get our tissue samples, which we used to use to grind up to homogenize, to extract and purify and characterize our enzymes. When you think of the whole frog being the size of your thumb and being, about 4 grams on average, and then you think, I'm working on an enzyme, I'm working on creatine kinase, for instance, that is found in heart. So how big does the heart have to be if the whole body is 4 grams. So I mean, basically we used to go through every spring. We used to capture, we used to have people capture for us these frogs just when they were coming out of freezing, so that they were still basically in season for being able to refreeze and re-experiment on. Because if you tried freezing a frog during the summer, its circadian rhythm, its biology has basically moved on to another season. So you can't do in the summer what would be done in spring. So we used to capture them in the spring, and we basically used to carry out our freezing studies. We would take batches of frogs and we would freeze them for 4 hours, one batch for 4 hours, and one batch for 8 hours, and one batch for 12 hours, and one batch for 24 hours. And then we would have some that we would freeze for 24 hours and that we would recover, we would thaw out for 4 hours. So basically all of these different experimental groups and control groups. And we used to go through these assembly lines, or rather, I guess it would be more appropriate to say these disassembly lines, where, the first person would start off by pithing the frog and cutting them open, and one person would extract the heart and put it into little vials of liquid nitrogen. The next person would, extract the lungs and put them into little vial of liquid nitrogen and all that. And I mean, we, as mass murdery as it sounds, unfortunately, we used to have to go through hundreds of frogs in order to basically accumulate enough tissue so that we would have enough of a sample to work with. Because, yeah, I mean, their entire body is on average 4 grams, but when you start looking at each individual organ and tissue, they're substantially less than that.
Yeah, that is well, the viewers at home can make it what they want of that. That is that's pretty impressive. You guys went through all those your disassembly line, as I guess you would say. Do you happen to know off the top of your head, like, if this research is like still going on, or?
Oh, absolutely. Yeah. So my PhD supervisor is still there, and if anything, he just kind of like accumulates more animals. The freeze tolerant frogs were just one of the model organisms that we would work on. There were different species of hibernating squirrels. There were freeze avoidant insect larvae. There were various snails, like, for instance, the marine periwinkle that you would find kind of in the main area that would survive intertidal anoxia. That was one of them. Another type of snail from Morocco. We would also look at the hot and dry side of the spectrum, not only the cold, freezing side of the spectrum. So we would get Xenopus laevis, the African clawed frog from the desert, that would survive dehydration and desiccation. And yeah, I mean, every so often he just kind of like seems to earmark another interesting animal that undergoes another interesting metabolic adaptation and kind of add it to the list. So, he keeps saying that he's going to be done at some point soon. Like, oh, next year I'm going to take on less research students, or next year I'm going to, but if anything, I mean, he just kind of keeps saying yes to too many undergraduates and prospective master's students and doctoral students, that if anything, the lab just keeps on growing and doesn't ever seem to stop. So yeah, it's absolutely still going.
I look forward to whatever the lab's doing now. I mean, that sounds, I mean, like we were talking beforehand, like, I mean, that's literally groundbreaking stuff that, that absolutely. Undergraduate students some undergraduates and graduate students are literally working on at universities. So, okay, so you finish up your PhD, 2008 at Carleton. Then you went to do your postdoc at Penn State. So
yes.
Transition, like, did you not want to go into industry first, or you just wanted to keep doing research?
I certainly wanted to keep doing research. Ironically, when I came out of my grad school, out of my PhD, I was of the mindset that I ultimately wanted to wind up at more of a research-centric university, as a principal investigator of a lab at such a university. And over time, that ended up changing, kind of, as you can sort of see, being at a primarily undergraduate university right now. But no, I didn't have the mindset. I mean, the idea that I previously had of going to medical school was long gone at that point, and I didn't really want to certainly go into a company, a big company, for instance, like Sanofi or Pfizer or something like that, where I would basically be a cog in a machine. I interested kind of, spearheading my research and doing my research at my pace quite a bit at that point. So no, at that point, I was pretty dedicated to kind of keep along the academic research path.
And then, so how did you end up at Penn State then? And like, what did you do at Penn State for your postdoc?
I mean, I think that I basically read an advertisement from the lab that I ended up joining. And, at that point, when you kind of get to postdoc, I don't know if everyone's postdoc is sort of this way, but at that point, it is almost like a veritable job application for, the same way that it would be in industry. I kind of sent over my CV and samples of the publications that I had at that point, had a little bit of an initial phone interview, and actually flew down to State College to interview in person. And yeah, so I was in the lab of an emeritus professor. In fact, if I name him, Steve Benkovic. He's actually pretty famous because he is a winner of a national National Medal of Science and Chemistry, which was presented to him by President Obama in, I want to say 2010 or something like that. So yeah, I mean, pretty famous guy. He was 70 years old by the time I started. He was already an emeritus professor. He was no longer teaching at Penn State. But he had a lab of, including myself at the time of starting, 15 postdoctoral fellows, no PhD students, no master's students, no bachelor students. Yeah, I mean, I went down, I interviewed. It seemed like a really good lab. It was obviously a huge I knew going in it was going to be a huge transition for me because from my undergrad to grad school, Ottawa and Montreal, I mean, they're both in Canada. They are technically in two different provinces, but they're basically a 2-hour drive from each other. Whereas now I was going into a different country. I needed some legal work authorization. I had TN1 status at the time, not an H-1B visa or anything like that. But, I needed to provide paperwork at the border to get legal work authorization. I was moving quite a distance away, especially being in State College. It's obviously not a major population center. To fly from where I was living in Canada to there, it's 2 flights, right? You have to go through either Philly or Washington Dulles and then over to University Park Airport, or if not flying, it's a heck of a drive. So yeah, it was a big transition, but it was kind of one of those stories in that. And I don't know how much this is applied to doctoral students anymore, but I was really told by my PhD supervisor, like, you must do postdoctoral studies abroad. You must go somewhere you've never been before. You must do something very different from what you've been doing previously. It is necessary to do that for your career path. So, being sort of young and impressionable in the way that I was, I just kind of took it as a given. In the time since, I've met people that have done their bachelor's, their master's, their PhD, and their postdoc all in the same Canadian province or all in the same Canadian state. Some of them doing multiple degrees at the same institution. So I mean, I don't know what is the right story, but this was kind of the path that was carved out for me. This was the path that I was gently, if not firmly, pushed along.
Yeah, I want to. So because we're going to return to this later, like the transition between Canadian to America when we talk about Greek life. But yeah. So what did you do? Like, what was your research in that lab?
The research in that lab was kind of picking up a little bit from what I had done with regard to graduate school. So, I mean, with grad school, I was looking at the regulation of all of these different enzymes leading to metabolic adaptation, which allowed for frogs to survive freezing, and come back to life. So I was looking at their regulation in terms of post-translational modification, right, phosphorylation. I was looking at their regulation by different allosteric effectors, which were especially known to increase or decrease in concentrations, right, change in flux in some way as a result of these physiological changes. And I was also looking at different subcellular compartmentalization. So, for instance, the relationship of enzymes, the proportion of enzymes that would be sort of unbound or free in the cytosol versus those that would in some way be tightly associated with the cytoskeleton or other insoluble portions of the subcellular structure. Basically, in that sense, we were investigating, okay, what happens when you homogenize a tissue and then you centrifuge out all of the particulate matter from that homogenate? Does your enzyme change in proportion at all between the supernatant and the pellet following that centrifugation? At Penn State, it was kind of building off of that. We were investigating something that had been very recently discovered or postulated called the pyrinosome, which was the coming together of different enzymes. I believe it was 6 enzymes in human cells, some of which were multifunctional. They would catalyze more than one biochemical reaction. And they were responsible for the de novo biosynthesis of purine. So along a metabolic pathway, they would convert phosphoribosyl pyrophosphate, PRPP, into inosine monophosphate, IMP. IMP being a precursor for adenosine monophosphate or guanosine monophosphate. And in cells that were cancerous, we were using HeLa cells, and therefore are rapidly proliferating. Hence, they need high concentrations of nucleotides in order to constantly undergo nucleic acid replication, right? DNA replications. In cells where their cell culture media had been starved of purines or other kinds of precursors that could be used in salvage pathways for purine synthesis, and therefore had to undergo exclusively de novo purine biosynthesis. What was observed using transfection of fluorescent proteins was that these enzymes would actually cluster together in these enzyme complexes in order to basically channel the product of one enzyme reaction to become the substrate of the next enzyme reaction, to become its product, to become the next substrate of the next enzyme. And basically in three-dimensional space, when you've got a metabolite in a metabolic pathway being handed off from one enzyme to another, the rate at which a metabolite fluxes through a metabolic pathway is no longer diffusionally limited because those enzymes are now clustered together in three-dimensional space.
I'm going to try and pretend I understand what you're saying.
I've done a pretty poor job if I'm an educator in that sense.
Well, well, mostly because I'm not really, I only took Biochem 1, so I'm not exactly, the most exposed to biochemistry jargon.
Yeah.
So I think.
Well, I mean, think about it this way, okay? Even in organic chemistry, right? You would see different catalysts being used to catalyze different organic reactions, right? So say you had a one-pot reaction where you wanted to go not just from A to B, but you wanted to go all the way from A to H, right? And like A would basically react with the first catalyst to become B, B would react with the second catalyst to become C, and so on and so forth. We'll say, for instance, that in, I don't know, an Erlenmeyer flask or a round bottom flask or whatever, you had all of these catalysts that were evenly dispersed throughout that medium. Well, at that point, I mean, basically A has to find and collide with the first catalyst in order to become B. B has to find and collide with the second catalyst to become C, and so on and so forth. But what if the catalysts were linked together as part of a macromolecular complex? What if they were linked together in a solid state, for instance? Well, the kinetics then of A being converted all the way to H would be a lot different than the kinetics if all of these catalysts were evenly dispersed and in somewhat dilute concentrations.
That makes a lot more sense. I understand that now. So
no one's coming back to take my teaching award.
no, okay, I understand that a lot better now. So what if like you basically had this one big jumbo catalyst that could just jump it? Okay, that makes sense. So then
exactly.
what was like the conclusion then? Like what was like the findings? Or like
I mean, I think it's still ongoing. It's still, and unfortunately what's happened, working on it for 2 years, the number of walls that I hit, the number of roadblocks that I hit were crazy. I mean, it was, it was a great lab. I mean, my PI is obviously an extremely successful PI, being awarded, a medal. And I mean, by the time I joined his lab, he was funded at that time by 3 NIH grants, massive NIH grants simultaneously. So, I mean, there's nothing to be argued whatsoever for his success. I think that there's something to be said for a PI who is ambitious, but can also intersperse with whoever their trainees are in their labs, whether they're undergraduates, whether they're master's students, whether they're doctoral students, whether they're postdoctoral fellows, someone who can intersperse or interplay high-risk projects with low-risk projects as well. And with Steve, the one, if I'm allowed to judge, the one caveat about his lab was that it was all high-risk projects. So either your high-risk project worked and you got results, or your high-risk project did not work and you got no results at all, possibly leaving you with your tail between your legs. After 2 years, I hit more roadblocks than actual results. In the time since, there's been increasing progress on that. There's also been, a little bit of refuting of what has gone on. There's been other papers from other groups sort of saying, yeah, well, is this a real thing? Is this a real subcellular complex of enzymes that come together, or was there some sort of stress induction caused by the change to media? Was there some kind of, did it result from the actual transfection of a plasmid encoding for a fusion protein between a de novo biosynthetic enzyme, purine biosynthetic enzyme, and a fluorescent protein? I mean, you're shoving all of these non-naturally occurring proteins into a cell, a cancer cell, a HeLa cell, which is already not quite in the right physiology to begin with. Right. Is this, like, how viable are these results, or how telling are these results? So I left that lab in 2010. I think even, now in 2020, there's still sort of questions about what actually that all means. Do I think that there are subcellular associations of enzymes? Absolutely, we know that for sure. We know that with some of the most basic textbook fundamental enzymes, that enzymes can actually, like glycogen phosphorylase, for instance, and the enzymes that regulate glycogen phosphorylase, they actually bind to glycogen particles. We know that there are enzymes that bind to the cytoskeleton. We know that there are enzymes that bind to the various leaflets, intracellular leaflet, extracellular leaflet of cell membranes, to the membrane leaflets of our organelles, like our mitochondria or our lysosomes or our nucleus or whatever. It's not an easy concept at all.
It seems like you have a lot of like variables going on. It's super complex, and it's hard to get like credible results to say without a doubt this is what's happening. Right.
Yeah, absolutely. And I mean, it's a type of work that lends itself best to sort of microscopy investigations. But when you actually start, blending up cells, when you try to actually start extracting proteins from cell and you're destroying that architecture within the cell, well, I mean, what can you then say about the types of proteins that you are removing and how they differ from when they were originally in that cellular architecture?
So, okay, so you finish up your postdoc. You kind of bounce around to a bunch of different jobs, but I kind of want to talk about your work.
I had a circuitous career.
Yeah.
Yes.
If you want to learn more about him, go to his LinkedIn where I found him, and you can see his various jobs. I'll put it that way.
Yeah.
But I do want to talk about now your current position right now at Colorado Mesa University.
Sure.
Maybe you want to shed some light on how you arrived at the position, why you wanted to be, well, I guess why you want to become a professor first, and then how you got that position, and then what you're doing now.
So as I mentioned, one of the things that I was looking for as early as when I was a doctoral research student and going into that postdoc at Penn State, I was interested in kind of doing things. I wanted to be my own boss in a manner of speaking, even though as a professor, you're not really your own boss. You still have a department head. You have, maybe depending on the university that you're at, a dean, you have vice presidents and president and all that kind of stuff. But I mean, you're by far and large in control of your own courses. If you are at a university where they support research programs, you are the principal investigator of your own research lab. You get to do things within reason, in a way that you want to do them, versus, as I mentioned previously, one of the reasons why I didn't want to go, why I wasn't hugely interested in a megalithic biotech or pharma company, was because, I thought, and maybe my line of thinking was incorrect, I feared really becoming kind of a cog in a machine. And actually, I did spend time in a biotech startup, which should have defied that paradigm, because a startup is not the same thing as one of these mega companies. But even there, even in that startup, I was told, oh, you have to be here at such and such a time, you have to leave at such and such a time, you're going to do this work, oh, this project isn't going as fast and isn't giving the results that we want to give. Especially because, in a company, you're trying to develop a product to put out on the market to generate income. It's all about the profits at the end of the day. It's not pursuing research or science simply for the sake of advancing knowledge. You're in it for the money when you're in a company. So, even in a startup, I discovered some of the qualities that I didn't really want to have in my career. Would other startups be that way? Would other larger companies be that way? Maybe, maybe not. I haven't gotten a sampling. I haven't gotten a taste of every possible industry, large and small, in the world. But I did kind of want to forge my own path, so to speak. I wanted to be in a certain measure of control in my day-to-day activities. I still love science. I love the idea of pursuing research, of discovering new things, of variety. When I 2 positions after Penn State, I actually was in a teaching and research fellowship at one of Canada's top primarily undergraduate institutions, one of its top liberal arts colleges, a place called Mount Allison University, which has about 2,400-ish students, and some really ambitious students, like some of the best students that I've ever taught, that just crave knowledge and crave challenge and want to be pushed harder and harder, like just mind-blowing kind of students. And I absolutely love that. So that's even where I started getting hooked on teaching and the idea of educating, and the idea of contrary to what I had when I was entering Penn State, I wanted to go more towards the area of research academia and like a big R1 university. Now, with having spent time at an actual R1 university in a lab that consisted only of 15 postdoctoral fellows, I started to change my mind a little bit, and started to change my mind even more so after the time I spent at Mount Allison, where I was working with almost exclusively, like 95% undergraduates, with maybe the odd master student here or there. I think there may be like a dozen master students at any given time at Mount Allison. So I really, really loved that. I loved working with students who, you know, you could do the most trivial thing in the lab, and it would be like a light bulb would go on, and it would be like a major discovery in itself. And speaking of major discoveries, I also discovered that despite the fact that I was not at an R1 university, it was certainly possible to obtain funding and recruit extremely ambitious undergraduate students who would work during the academic semesters and during the break periods, like the summer and so forth, and who could actually make documentable, reproducible research progress that would lead to peer-reviewed publications. So with that, I kind of learned that I could have my cake and eat it too, in a way. And so, you know, I was looking for tenure track positions for a while. Some people get, you know, some people have the right combination of skills and availability and publications and experience and timing and luck and, you know, whatever the case may be, that they may wind up in a tenure track position, sometimes right out of their PhD, or maybe after a couple of years, 1, 2, 3 years of postdoctoral experience. For me, it took 11 years after the completion of my PhD to nail a tenure track position at Colorado Mesa University. So it was a long, long path. I'm not gonna lie at all. I many times thought about throwing in the towel and maybe going to like one of these industry positions, despite being a cog in the machine, or maybe even going to a completely different path entirely, maybe doing something like law school and going into patent law, or maybe doing some kind of business degree and going into business or communications or marketing aspects of science or something like that. But I stuck with it out of volition and maybe a little bit of stubbornness. No, probably a lot of stubbornness. And so yeah, I ultimately clinched it.
Mm-hmm. So what is the research you're doing now? Because you said you kind of like to pursue like your own, well, control your own destiny, I guess, in some way. So what are you doing there with your undergraduates?
So still along the path of basically enzyme regulation, and enzymes being the regulator of global cellular physiology. Still, again, being ingrained with, you know, the family experiences of growing up with a diabetic family, still wanting to find a way to reverse that, and still kind of taking the lessons that I learned from freeze-tolerant frogs and other kind of stress-tolerant animals, kind of applying those lessons as well. Basically, what I'm looking for are pharmacophores that are capable of regulating key enzymes, key signaling and metabolic enzymes in such a way that they reverse insulin resistance. So I'm focusing on specific types of functional groups. I'm looking at catechol and guaiacol, which are found a lot in natural products and typically found in foods or beverages that are known to lower blood glucose or to lower excess blood insulin levels, and actually seemingly sensitize insulin signaling within patients that have metabolic syndrome or that have full-blown diabetes or something like that.
So yeah, so this, I know this research is really basically brand new. So this is kind of like you don't really like have any results yet. So let me try and get this straight. So the functional groups catechols and guaiacols, you predict they modulate enzymes of insulin receptors?
Well, not necessarily of the insulin receptor themselves, like not necessarily the insulin receptor tyrosine kinase, but something that is either directly within the insulin receptor signaling pathway or something that is peripheral to the insulin receptor signaling pathway that will have crosstalk with enzymes in the insulin receptor signaling pathway, or alternatively, metabolic enzymes that are downstream of insulin receptor signaling. So like, for instance, we were trying to work on, which actually proved to be, we had to halt this project pretty early because it turned out to be very, very cost ineffective using the infrastructure and resources that were immediately available to us. Trying to find a drug for a phosphatase enzyme called phosphotyrosine protein phosphatase 1B, PTP1B. And this is actually a pretty widely known drug target in a number of different diseases, in cancer and Alzheimer's and diabetes. And basically what PTP1B is it's your off switch for your insulin receptor. So your insulin is secreted by your pancreas. It travels through your bloodstream to all of your different tissues throughout your body, and it will bind to a cell surface receptor on all the different cells in all of these different tissues and organs, and basically tell these cells by binding to the insulin receptor, hey, the reason I'm being secreted from the pancreas in the first place is because we've probably just taken in nutrients, blood glucose has risen, it is now time to import blood glucose and do something with it, you know, burn a little bit of it as fuel, replenish ATP levels, build storage molecules such as triglycerides and other lipid-based molecules, build your glycogen polymer for such a time between meals when you're fasted and then need to break it down, like you would withdraw money from a savings account during a dry spell. You know, build muscle, do anabolic functions. However, despite the fact that the insulin hormone, the insulin peptide, binds to and activates the insulin receptor, that insulin receptor cannot remain activated in perpetuity. You cannot have this growth and proliferation signal that doesn't stop ever. That's kind of what leads to cancers, right? This proliferation and growth signal that never turns off. So after a time, basically another enzyme will come along and turn off the insulin receptor, such as PTP1B. It will take all of the proteins that have been phosphorylated by the receptor tyrosine kinase, and being a phosphatase, it will dephosphorylate those proteins. It will literally hydrolyze off the phosphoryl group, changing back their electrostatic interactions, changing back their configurations to an inactive state. So basically, if you're having problems with insulin receptor signaling, if you're starting to build up insulin resistance, one of the ways of combating that is to prevent the off switch from basically turning off their insulin receptor signaling, to keep that insulin receptor signaling as active as possible. So, you know, we tried to determine whether or not some of the guaiacols and catechol that we were looking at were going to be an inhibitor for PTP1B. And we very, very quickly discovered that the cost of, you know, purchasing PTP1B would be extremely prohibitive, like you pay through the nose for it. So until such a time that we can produce PTP1B in-house to work with sustainably at much lower cost, you know, we've shelved that project. But we're looking at other enzymes now. For instance, one of the metabolic enzymes that we're looking at is glucokinase, which is an isozyme of hexokinase, the first enzyme that you would see in the glycolytic pathway of carbohydrate metabolism, except that in the liver, it has a bit of a different affinity for glucose. And typically, the purpose of phosphorylating glucose in liver cells is not necessarily to catabolize glucose all the way through, for instance, oxidative phosphorylation to CO2, but actually to phosphorylate glucose to retain it in a cell so that it doesn't, you know, drift back out through glucose transporters, and actually to store it as glycogen. Well, if you increase the activity of an enzyme like glucokinase, that means that more glucose that is taken up by liver cells is going to be phosphorylated and trapped in liver cells and stored as glycogen. The more glucose that you retain in the liver rather than out in the blood, the more you're going to decrease your blood glucose levels, the more you're going to rid yourself of things like glycated hemoglobin and advanced glycation end products, the more your inflammatory response is going to decrease, the more that you should be decreasing insulin resistance and increasing insulin sensitivity. In a very long-winded nutshell.
Yeah, in your nutshell, the size of like my house, like that's what you're talking about here.
You know, I mean, what I really love, especially being a biochemist, and this is one of the blessings and curses of being a biochemist. I can talk to you about the actual guaiacol and catechol functional group. You know, like I can even refer to your previous podcast guest, Victor, who was actually working on its resveratrol derivatives, right?
Mm-hmm.
And resveratrol actually contains aromatic groups which have alcohols on them. Now, one of those aromatic groups actually has 2 alcohols on it, and they are in a meta position, right? They're like at 1,3 positions. So the aromatic group in those 2 alcohols as a whole is referred to as a resorcinol moiety. Well, if you're to have an aromatic group with 2 alcohols in an ortho position as opposed to a meta position, that is catechol as opposed to resorcinol. And if you're to have those 2 alcohol groups in a para position as opposed to an ortho or a meta position, well, that would be a hydroquinone, right? So depending on the position of the alcohol groups relative to each other, ortho, meta, para, you basically have a catechol, a resorcinol, or a hydroquinone, you know, and they have different bioactivities. As a whole, they are referred to as polyphenols, but they have different bioactivities associated with them. So being a biochemist, I love talking about that kind of organic functional group and what we would call in pharmacology and toxicology quantitative structure activity relationships, or QSARs. But being a biochemist, I also love talking about metabolic regulation and enzyme catalyzed pathways, you know, multi-reaction pathways, and the physiological events that lead to one type of activation versus another type of activation. And the pendulum for a biochemist should be able to swing freely between chemistry and biology. Unfortunately, specifically like in a university that has a very, very departmentalized structure, they always try and pigeonhole biochemists into one group or another. You must be a biochemist that is chemistry leaning or a biochemist that is biologically leaning, and never the twain shall meet. And that, I think, is a fundamental incongruity of what it actually means to be a biochemist. So yeah, I mean, I love, you know, going on a tangent either towards the chemical side or the biological side, but you know, depending on who's listening to me, what my audience is, they may say like, what the hell are you talking about?
And that's okay. Like that's okay. Like these are designed for you know, a lot of people to listen, and some people aren't even get it. Sometimes I don't even get what people are talking about, and that's okay. But something that you highlighted that I really love is when people try to tell me about, like, you know, what's so special about chemistry and organic chemistry in specific. I'm like, and you just kind of highlighted it. Like when we talk about the positions, ortho, meta, para, just changing the position of a functional group changes the biological and chemical properties of what you're working with. Like it could be, you know, planets apart, like differences. And that is something that should be worth studying. And I think that everyone should learn about, right?
Yeah.
But so first of all, I love your enthusiasm that when you speak. I could see why you are an educator. You're very passionate about it and very enthusiastic, and I think that's awesome.
Thank you.
I kind of want to circle back now to Greek life as we can kind of wrap up here, because you're a bit of a special case. We were talking beforehand. that you actually joined Tau Kappa Epsilon as a graduate student, not as an undergraduate student.
Right.
You kind of want to shine some light on this decision, maybe why you didn't. Well, as you talked about before, you kind of worked your butt off in undergraduate, didn't really do any extracurriculars. But what was the mindset change to join a fraternity at graduate school?
Yeah, and I mean, you know, I didn't even realize really that there was much Greek life. One, because as you know, we've said, I was working to kind of turn around my poor academic performance of my early on portion of my undergraduate degree, such that I was just burying my head in the books. I also didn't even really notice until the final year of my undergrad that Greek life even existed at all at Concordia University, because, you know, of these two campuses. One, you know, I spent the first few years in the downtown campus, the Sir George Williams campus, which is in the downtown core of Montreal, and it's really the type of university that, I mean, there's no residences or anything like that for, you know, for students to live on campus right in the middle of, I mean, you can get an apartment in downtown Montreal, you'll pay through the nose for it, but it's not like a contained university campus where Greek life really thrives on students who live on campus, students who are residential. In the final year of my undergrad, the science departments moved from the downtown Sir George Williams campus to the Loyola campus, which is a more contained, outside of downtown, green and closed campus. And actually, I remember an instance of being in this kind of student lounge called Dieni Lounge and sitting down, eating a snack at a table and kind of like looking around the student lounge, which is the university had this architecture which was very reminiscent of its old Jesuit roots, almost very, very church-like, because Loyola College in Montreal, like Loyola University in Chicago, both Jesuit institutions, both like kind of like founded and taught by religious orders. So I'm looking around this place and looking around this lounge, and I see these murals on the walls of all of these Greek crests. And, you know, later after the fact, of course, I realized that one of them was actually the teak shield, you know, like it was up there, which I didn't really know at the time prior to my initiation. But so how did I stumble upon Greek life? How did I stumble upon this in graduate school? Much the same way as, you know, as how I wound up in biochemistry. Kind of the current took me where they did. I lived the entirety of my graduate school life on campus because growing up and doing my undergrad in Montreal, I was originally and lived throughout my undergrad in the suburbs of Montreal, whereas, you know, these two campuses of Concordia were more towards the center of the island. And it was like an hour-long commute in each direction, twice a day, every day. And I was done with that by the time I hit graduate school. And so I lived on campus because it doesn't matter if I was in the lab until, you know, 5 p.m. or 9 p.m. or 1 a.m. or whatever the case may be. I wouldn't have very, very far to go before I would be able to crash on my bed, you know. And the beauty with Carleton is that actually every building on its campus is linked together by a network of underground tunnels. So on those 40 below nights, you don't have to even worry about a cold walk to your residence building. You just kind of like tunnel through the network of underground tunnels, and you don't even need to bring a coat with you. Yeah, so I lived in residence, which was nice and convenient. But the thing about living in residence is that there's a lot of turnover. I thought, you know, a lot of people would be of the similar mentality of myself, especially among doctoral students. I thought, okay, once you kind of get to campus and you park yourself on campus and you discover how convenient it is to live on campus while you're working on campus, you might as well stay there. But, there were a lot of people who were pursuing master's degree or non-research doctoral degrees, and they would live in graduate residence maybe for a year, an academic year being more like 8 months rather than a full 12-month year. And they would leave. So it would be constant kind of turnover. And I would meet people and keep in contact and lose in contact and whatever. And one of the people that I met was a little bit of a slightly older, mature undergraduate who was rushing a fraternity. And I thought, oh, that's weird. And and so he rushed and he went through it. And I thought, aren't fraternities kind of, this, that, and the other, because you get the stereotype, right? Like you hear and see in the movies about what you expect a fraternity to be. And he said, no, it's not at all like this. And so through that, I got introduced to other members and started, associating with them more. And one of them who I grew particularly close to, and it was actually while I was pursuing doctoral studies in biochemistry, he was pursuing an undergraduate degree in biochemistry, not biochemistry, just plain chemistry. So, we kind of were simpatico from an academic sense, as well as being on other same wavelengths. And he said, have you ever thought about it? And I thought, not a bad idea, considering the turnover and the transience that I'm experiencing in other social aspects of my life. By far and large, I meet someone, particularly in the community in which I'm living in graduate residence, and I barely get a chance to know them over 8 months before they decide to go live off campus or something like that, and they're out the door. I mean, it would be nice to have a little more of a connection with people. So I thought, I'll give it a shot. And lo and behold, next thing I know, I'm being initiated, and then I'm a brother.
That's honestly an incredible story, because I think that, well, one, it shows that, Greek life is far beyond your 4 years as undergraduate, because look, you go to a bigger school, you can make it what you want. You can go see sometimes those stereotypes are true. Like, they are. Like, there's definitely true. There's no doubt about it. But I would say about, 80, maybe not 80%, but a large majority of fraternity life is not what you see in the movies. Like, it's not even close. It's people trying to do good, like really, like they're trying to do good, and they want the best for everyone, and they want to improve others around them. And I truly live by that. So it's really good to see that even in a graduate sense that, you took the chance and joined fraternity life. What do you think some of your favorite moments are within the fraternity, at least?
It's to try and think of a specific moment is hard to kind of define any particular moment. I think that some of the best times I experienced were actually the summer immediately following my initiation, because as a graduate student, I was on campus and I was in the city 12 months a year doing research. I mean, I wasn't leaving during the summer, because if anything, the summer, particularly once you're done the few graduate level courses that you have to take, okay, you're still going to have some TAing to do. I had, it's part of the stipend that you're allotted, is the duty that you have to perform as a teaching assistant. Okay, that doesn't happen during the summer. There are no courses in the summer. So the summer is prime time to do uninterrupted research as a STEM graduate student. Unfortunately, the vast majority of other students that we know on university campuses, be they undergraduate or graduate students, don't share that kind of timeline. They're not STEM students. They don't do summer research. They disperse. They go back to wherever they came from for the summer. So campuses have a way of emptying out. Residences have a way of emptying out. Even though you're doing research in your lab and you're surrounded by the people that you work with in your lab day in and day out every day of the summer, you know, if you're actually looking for some change of ideas besides the people that you're working with in your lab, whether or not you get along with them famously, you know, or not, to have any kind of community outside of your lab, it can be difficult in the summer, regardless of how large or small a population center that you live in. It's even worse in smaller population centers because those really empty out in the summer. But, you know, one thing that I did have definitely in that first summer following my initiation, where there were a lot of teaks around in the area, and I spent a lot of time with them. Pretty much any time that I wasn't working in the lab, which obviously was a considerable amount of time, I would spend almost every iota of my free time with my new brothers. And they made, in contrast to previous summers, because I didn't join immediately upon being a graduate student either. It took a few years of being a graduate student before I became a teak. It made that summer a lot more tolerable, and I would say more enjoyable than the previous summers, in which I was living in grad residence during the summer, and I could open the door of my res room, of my residence suite, and like basically look on either side of the hallway and listen for any activity in my residence floor, and it would be dead quiet. Like there would not be a single person around. Whether there was anyone actually living in grad residence, I mean, you felt like the loneliest person in the world. And if you were sort of like a late night owl like myself in the lab, where you're the last person to leave the lab on a given day, and you just kind of take that walk at the end of the day from the lab where you were the last person, not seeing a soul on campus, to reaching your residence building where you still don't see a soul, is like, am I in a wormhole? Like, am I the last person on this planet or something like that? So it made a huge amount of difference from a community sense, from just like a day-to-day keeping your mental health about you sense.
Yeah, I completely agree. I think, especially like, at least for myself, like I come from a smaller chapter, like we've only had like, 20 or so guys, but you kind of, when you join, like it just opens the door to everything. Like, I mean, we wouldn't even be sitting here right now, and probably not even like, I mean, initially knew you were probably a teak, so it just opens the door to everything, and then it just you feel connected, you feel in this whole sense of community. So I always tell people to give it a shot. At the bare minimum, give it a shot. If you don't like it, you don't like it. Fine, all right, but give Green Life a shot. But Chris, as we begin to kind of wrap up here, I want to ask you this: what is some advice that you give to either your current students or like prospective students, whether in general or within the sciences? Like, what's some advice that you like to give to your students?
I mean, it's kind of funny in the way that you just said you have to give Greek life a shot. As with Greek life, you have to give anything a shot. I think that science is an incredibly difficult path. Whether it's biochemistry or it's chemistry or something else, it's very, very, very difficult. Whether you're an undergraduate, whether you have lofty ambitions of going to graduate school, whether you want to go to medical school, pharmacy school, veterinary school, whether you just want to get a job in the industry, there's difficult times ahead, even at the best of times, even when we're not mired down in a global pandemic. Teaching this semester, this fall semester, which we've just wrapped up, was a very unique experience. I saw student sort of perceptions and behaviors in this most recent semester that I had not previously seen in 8 semesters of teaching. And I don't know if it's having to do with the fact that we are kind of mired in a global pandemic. There's some education that's happening online. Not all education is happening online. My university was on site as much as possible. Some of the larger class sizes had to kind of rotate which students were able to attend class in person on which days. I was lucky in the sense that I was teaching a biochemistry course where the classroom we were assigned was large enough And the number of students that we had registered was small enough that all of us could fit, even when socially distanced, into the classroom in the same time. So as a whole, aside from the fact that we were all there wearing masks, it wasn't really, for my course, a different semester than it should have been in any other course, aside from when we were supposed to, at Thanksgiving, go away for Thanksgiving and hold the last week of the semester and final exams online, because university didn't want students coming back and like bringing back with them whatever they had caught from their families. We ended up going online a week earlier than originally expected because cases were starting to rise in Mesa County, but we actually got the bulk of the semester as much as we could in person. And even with that, I noticed like this just sort of like, bleh, like students just kind of didn't want to try. They used the pandemic as a blanket excuse for everything. How hard some concepts were, how difficult a course was, the idea of seeing things on a computer screen versus, I don't know, drawn on a whiteboard or something like that. And the thing I would say is that give it a shot, as you said, with regards to, just give it a shot, give it your best, give it all that you can. We're all going to uncover difficult patches. I certainly did, right? As I said, my experience in pre-university college and my first year of my undergrad was detestable. I was on academic probation. I had to basically put nose to grindstone to ultimately wind up as a Dean's List student, but I did it. We're all going to see rough patches, but the thing is, if you don't rise to a challenge, if you program yourself or, unfortunately, listen to advice, poor advice, that is given to you by people who are saying to back down from challenges, to take the easy road through life, if you train yourself to be like that, you're going to be forever not responding and not rising to challenges and not overcoming the challenges. I personally think that it's better to try and rise to a challenge and fail rather than to not even bother trying at all. That's my personal, and I mean, I've taken my bruises from the failures that I've incurred in my life, but at least I've always tried as much as I possibly can. And what I've noticed this semester as a scientist, as an educator, scares me a little bit for the present and also going forward once we eventually, hopefully sooner rather than later, clear this pandemic. I want to see more effort. I want to see more trying. I want to see more gusto from young students and young scientists and young prospective people who are going to go into doctoral degrees and want to go into medical school or whatever the case may be. Just, kind of take that and rise to a challenge. Don't avoid a challenge. Don't back down from that.
Yeah, I completely agree with what you're saying. I see exactly what you're saying, especially right now as an undergraduate student.
Yeah.
God, I mean, how many students use the pandemic as an excuse to just not really try in class, maybe not even try in their clubs, right? You're a part of clubs, organizations, and well, the pandemic's here. We can't really do recruitment all that well. How are we going to do recruitment? Or, I don't really feel like doing all these events. Well, all right. Well, you have to be adaptable in life. And I get, there is a point where maybe you're on the computer screen for too long. Maybe you are. There is a point where, all right, go ahead, take a break. But to use the pandemic as an excuse every single time is, well, I think sometimes cowardly. And I think that you are doing yourself a huge disservice to not try. Because look, and I believe I try and live this every single day. Look, you could have not tried during the pandemic, and you could have not done that. Or you could catapult yourself above others because others are thinking the same way, like, pandemic, do I really feel like doing all this right now? Well, 75% of students are thinking the same way. So use that to your advantage and rise up and get something done, because a lot of people are just backing down right now. So, but I agree. You got to be adaptable in life. You got to be perseverant. So take advantage of it.
Well, what I say is, especially to some of my students that I know want to, especially teaching biochemistry courses, I know that I constantly have it, hit over my head. A lot of my students want to go into healthcare professions, and I say to them, I try and shock them a little bit and say this, look right now at all of the doctors, the nurses, the orderlies, all of those who are in hospitals, who are dealing with all of this sickness and death right now. And you see that like they're constantly images in the New York Times and whatever of like doctors just like huddled into little balls from pure exhaustion and exasperation, barely able to hang on. And I say to my students, you want to be a healthcare professional. So that doctor in that picture right now is going to be you in the next pandemic. If you back down from challenges now, how are you going to handle what all of these healthcare professionals are going through when that happens to be you in the next healthcare emergency, in the next crisis?
Yeah, that says it all right there. Like, what are you gonna do? And in some ways, like, God, like, are you thinking about STEM in specifically, some students cheat on their exams. It's like they take the easy route, and it's like, well, you're kind of doing yourself a disservice in the future. In some ways, I'm like kind of worried about our future engineers. Like, these there's memes about the civil engineers who went through COVID. It's like, are they going to be able to build a bridge or something like that? It's just like some memes, but there is some truth in it. It's like you're only doing yourself a disservice. So give it all you got. You got to be adaptable. Don't use the pandemic as an excuse. Jump ahead. And that's what I say to people.
Absolutely.
Chris, I want to thank you so much for hopping onto the show today.
Thank you. It's quite a hop. It's been over 2 hours.
I love it. And you know what? We still have more to talk about, which is why I was going to say you're getting on in the future. We're going to do this again sometime in the future because there's still more to talk about.
This would have been great with like a couple of beers, just like while away the hours.
Listen, Joe Rogan in their podcast, they drink whiskey and stuff like that. I'm of age right now. I don't care. I'll do whatever.
Nice.
But I definitely want to bring you on in the future. There's still more to discuss. But thank you so much for coming on. I know I really appreciate it and getting my first guest, my first non-Widener faculty, and well, brother, I guess too.
Absolutely. Like I say, it's been a very long time since I've actually, in the many jobs that I've held, as you pointed out, it's been in my circuitous career a very long time since I've been at a university with an active TEAC chapter. I think the last time was actually, I was doing some adjunct teaching at my alma mater, Carleton, between 2014 and 2016. And so the chapter in which I was initiated was obviously still there. But so from 2016, I left to go teach at a liberal arts college in Collegeville, Ursinus College, in fall 2016. So from fall 2016 to present, it's now been over 4 years. I've not been anywhere in the vicinity of an active TEAC chapter. And even though I do kind of, I'm still involved to an extent with TEAC. You may have heard the DEI initiative that they recently launched, and the parent committee and the subcommittees that are involved. I'm on the History, Traditions, and Education subcommittee of the DEI initiative. So I do still Zoom, with alumni and actives, but I haven't been in geographic proximity to any TEAC in over 4 years, which is sad. It feels like I'm being apart from family.
Yeah, I don't even know if I went without TEAC for 4 years, man. I don't even know what I would do. But the DEI
4 years and 4 months, like something like that. Yeah.
It stands for diversity, something, and inclusion, right? Is it
diversity, equity, and inclusion?
Yeah, it's a new initiative that TEAC put forward to be more accommodating, I guess, to everyone. And I know there was last week there was a workshop on it. All of our officers went to that. Tonight we have chapter, and we're going to talk about that tonight. So I'm looking forward to what the the younger guys learned, because I already got all the DEI stuff done.
Yeah. Well, give my best to all of our brothers in your chapter, please.
I look forward to next time there's a conclave. I know I'm going. Next in-person conclave, I know I'm going. I hope to see you there if you go.
Yeah, likewise. I've always wanted to I haven't been to one yet, but yeah, I would really love to.
But again, guys, if you like the content, please like and subscribe. But until then, this is episode 15. Thank you again, Chris.
Thank you so much. I really appreciate it.
All right, see you, everyone.
Unless I stuck by